Hey guys, today we are discussing about the histogram and this is skewness. Histogram, it's mean what, right? Histogram is a graph. So we plotting a graph for a histogram and any data set we have in data set and that someone is told us to graph a plot, right? A proper histogram. So how do we make a histogram, and what is the different types of skewness of a histogram? That's we will today see, right? So start with the so we will start with the definition of a histogram. A histogram is a graphical representation of the distribution of a numerical data. If in a estimate of the probability distribution of a continuous variable, and it's used to visualize the shape, central tendency, and variability of a data set. So we are talking about the concepts of a histogram and how the means, median, and mode and central tendency how to define on the histogram graph that we will see in today lectures, right? The first understand the we start with the graphical representation. That's we have a data, right? Data points. So first we understand the examples of a histogram, and we have data like 11, 12, 14, 15, 18, 24, 26, 30, 35, 36, 37, 30, 40, 41, 42, 43, and 50. That have we have a data, right? So first we are define the size of the range. So we have size of the beans of size is beans of size is in between 0 to 50, right? The size of beans is in between the 0 to 50. Okay, and we have a total number of beans we are considering the we have beans considering the 10, right? And a bean size is nothing but 50 divided by 10 is nothing but 5. This is your bean size. This is your bean size, right? So first you plotting a graph for that statement, that is what is the size of bean is a 5, and is a bean number is a nothing but is a bean number, right? This is your bean number. So we restarting the graphs. So how looks like a graph for that statement? So first we are plotting a graph. This is nothing but start with the 5, then 10, then 15, 20, 25, 30, 35, 40, 45, 50, and nothing but is a 55. And what is that? This is the age. In a graphical representation, this is the age, right? And this is the bean size: 1, 2, 3, 4, 5, and let's consider 6 is a beans, right? So we are plotting a graph. So we see the in between the value, just like a 5 to 10. How much value are in between is a 0, right? And then 10 to 15 is nothing but 1, 2, and 3. So your plot is in that. This is plotting the plot. This graph is look like that, right? And then 15 to 20 is just very one value, right? And then 50 to 20 to 25, 20, 20 to 25 is a just very one value. This is a 24, right? This is only one value, 24. This is a 35, 25 to 30 is just a one value, right? We have 30, but we not considering 30 on 25 to 30, right? That understand. We are not considering this 30 value in between the 25 to 30. We have just one value is nothing but 26. So first understand is a 30 in between 30 and 35 it is just a one value, and then 35 to 40 it's only 1, 2 and 3 value. We are not considering the 40, right? So we have 3 points. So a plot look like a that. This is a 3 value, right? I hope you understand. And this in between 40 to 45 is nothing but 1, 2, 3 and that is a 4. That is a 4 in between 40 to 45. 40 to 45 and 45 to 50 is nothing but just a one value is nothing but 50. 40 to 45 is nothing but 50. Sorry, 40 to 45 is no value, right? And then 50 to 55 is a one value, that's carry. We have only one value. That is your plot. So how to graph your we are graphing the histogram plot. So histogram plots look like that. This is called the histogram plot, right? This is your histogram plot look like. This is your histogram plot for that segment. So we are first talking about the histogram plotters are done. Okay, so we start with plotting of another segment of skewness. What is skewness? Okay, see the skewness of a graph, right? So we will start with okay, we will start with the skewness. What is the skewness? So we will start with the skewness of a graph. This skewness skewness it's what skewness in it's how the graph are perform or how to graph look like, right? This is your skewness of any histogram graph, right? So first we understand the symmetrical graph. Symmetrical graph, right? So we talking about the symmetrical graph. So how the symmetrical graph look like? So if you that understanding that thing, then is our x-axis and this is y-axis. So if you're talking about the symmetrical graph, that's a plot. The histogram plot look like that. Our histogram plot look like that, and that is your graph, right? Is a symmetrical graph in a both side, and you talking about that's mean, median and mode. In that is a symmetrical graph. It's gonna look like a same in a both. In a that's a both are equally distributed. That's called your symmetrical graph, right? Is nothing but symmetrical graph, and we agree, if in that case the mean, median and mode, mean median is equal to mean is equal to mode, and mean, median and mode are three of value are equal to each other, and symmetrical graph, right? Is a three type of graph. Since we understand the symmetrical graph, the mean, median and mode are three are in the same size. So we are plotting a box plot. How to look like a box plot? Box plot. So this is our box plot. This is your box plot, also symmetric. It quadrant equations 1, 2 and 3 are equal to each other, right? That is your box plot for symmetrical graph, right? So we start with okay, then we will start with the concepts of that we are done with a symmetrical graph. So then we are starting with a right skewness. What is the right skewness? Okay, understand the right skewness, right? what is the right skewness of any graph? So we will start with the right skewness. That's a look like in a graphical representation. We the right skewness look like a graph is you see that just like that. X-axis and this is a y-axis. So symmetrical graph is nothing but look like that way, right? This is a in other word, the symmetrical graph is look like that. That is called as the right skewness. It means highly amount of data is surrounded in a toward the x-axis, sorry, y-axis, right? This is the histogram, and this is the right skewness of any graph. So we are talking about the mean, median, and mode. How to distribute it, the mean, median, mode. So in that case, is the mean is equal to median, right? And what about the mode? The mode is less than or equal to mode is less than or equal to mean and median. That is your graphical are distributed in a different form. Okay, you understand that thing. And if you plotting a box plot, so your box plot look like that is a q1, q2, and q3. What is q1, q3, and q in nothing but is a quartile equations. I hope you understand. It's a quartile equation is nothing but is a 25. It's mean a 25%, is a 50%, and is a q3 is nothing but 75%. That's a look like a graph of a box plot in this quartile 1, quartile 2, and quartile 3. We are talking about the left skewness, right? We are starting talking about the left skewness of any graph. How to look like the left skewness? Left skewness. So left skewness will look like a graph, just like we are plotting a graph. And that's your keyword or this is your left skewness, right? This will graph look like the left skewness of a graph. In simple term, if it says that this will graph look like in that form. That is the left skewness of any graph. In that situations, if I'm talking about the or is one one more name, you say that is a negative skewness, right? Is also called the negative skewness of any graph. Okay, so we are plotting the box plot, and how quartile equations look like. In that case, if quartile equations are distributed just like that, is q1, quartile 1, quartile 2, and quartile 3. That is your box plot look like. This is your histogram skewness of any graph. Graph we are distributing the graph. So that is your box plot as well, right? So that's all done, and we are meeting next video.